Hello, students. So today's topic of discussion is empirical formula and molecular formula. So let's first define what empirical formula is. So empirical formula is nothing but formula of a compound, formula of a compound in terms of simplest mole ratio. So that means first you will have to calculate moles of the elements present in the compound. Then you will have to take the ratio of those elements, moles of those elements, and then you have to just simplify that mole ratio. And to enhance our understanding, I'll just give you an example. Suppose let's take a molecule glucose. The formula of glucose molecule is C6H12O6. Now, if I understand this molecule in microscopic terms, as we did in the video number one, so one molecule of glucose, since we are talking about microscopic levels, so obviously I'm taking one molecule of glucose. So I can say that one molecule of glucose contains or consists of six atoms of carbon, 12 atoms of hydrogen, and six atoms of oxygen, right? And if I read this molecule at macroscopic level, so for that I need to take the molecule in bulk, and bulk in chemistry means mole. So if I take 1 mole of glucose molecule, so it will consist of, now since everything has come in moles, it will have 6 mole of carbon atoms. As I said in the video number one, tip number one was that the interpretation and calculation remains the same whether you are dealing in microscopic or macroscopic level. So 6 mole of carbon atoms, 12 mole of hydrogen atoms, and 6 mole of oxygen atoms. So as per the definition, what is my mole ratio coming out to be? It is coming out to be 6 is to 12 is to 6. This is my mole ratio. 6 is to 12 is to 6. And if I try to simplify it, so I divide everything by 6 and I get 1 is to 2 is to 1. So my glucose has molecular formula C6H12O6. And empirical formula, as I've calculated over here, the mole ratio originally was 6 is to 12 is to 6, which has been simplified to 1 is to 2 is to 1, and you don't write 1, you just simply write it as CH2O. To understand it further, let's solve a question based on empirical formula. Okay, so now to understand empirical formula better, we have this question in front of us which says that what is the empirical formula of the compound containing 40% sulfur, 60% oxygen by mass? So it has 40% sulfur and 60% oxygen by mass. And I'll just repeat the definition of empirical formula. It is nothing but simplest mole ratio. So first we need to focus on calculating the number of moles. Number of moles of what? The elements present in the compound. So as per the question, there are two elements present in this compound. One is sulfur. I'll take the symbols because I obviously have to generate formula. So symbols are helpful for me. So I'll take the elements as sulfur as given in the question and the element oxygen, and I'll make a column of serial number. And this tabular form of working generally helps you, calculate easily the empirical formula. So number one, number two. The next column that you are going to make is of given mass, because to calculate moles, as we understood in video number one, to calculate moles we need to have the given masses, because number of moles is nothing but given mass by molar mass. The formula for moles is given mass by molar mass. So working on those lines itself. Now, in the question, if you read carefully, they haven't given you masses to be precise. Instead, they have given you percentages by mass. So the best part is that in these type of questions, you have to assume the percentages as given mass. So sulfur's percentage was given to me 40%, so I'm assuming it to be 40 in terms of mass as well, and oxygen as 60. And do remember that you, as a precaution, just check every time in the question that the total percentage should come out to be 100%. So over here, 40 plus 60 is coming out to be 100%. This assures us that only these two elements are present in the compound. There is no third thing in the compound. Okay. Now, since we have to find out moles, and the next strategy for finding out moles is, now we have taken the given masses. All right. So now we have to focus on molar mass, and molar mass will be figured out from the periodic table. For those who don't know the molar masses, you can refer the periodic table. And for those who remember, well and good, that's great. If you remember the molar masses, so molar mass for sulfur is 32 and for oxygen is 16. The next column would be of number of moles, and number of moles as per the formula is given mass, which is 40 for sulfur, and molar mass 32. So 40 divided by 32 and 60 divided by 16. Now I will be using my calculator to calculate 40 divided by 32, and that comes out to be 1.25, and then 60 divided by 16, that comes out to be 3.75. So I have calculated the moles. Now it's time for calculating the ratio. And for calculating the ratio, like in the previous example that I was explaining, the mole ratio was 6 is to 12 is to 6. And you divided everything by 6 because 6 was the smallest number of moles. So over here also we are going to follow the same strategy. We are going to divide both the moles with the smallest number of moles, and the smallest number of moles is what? 1.25 is the smallest, so divide everything by 1.25. So I get 1.25 divided by 1.25 as 1, and 3.75 divided by 1.25 gives me 3. So my simplest mole ratio comes out to be 1 is to 3. Hence, my empirical formula of this compound would be S is 1, and I said we don't write 1. O is 3, so SO3 is my answer. Empirical formula of the compound. So what is empirical formula? A quick recap. It is simplest mole ratio. So always remember that you have to find the moles of the constituent elements. So elements were sulfur and oxygen. For calculating moles, you need given masses. So masses were not directly given to me. I took the percentages as given masses. Then I divided them by their respective molar masses. I calculated the moles. I calculated the ratio by dividing the moles with the smallest number of moles calculated, and then simplifying it. So I just got the simplified version as 1 is to 3. So my empirical formula is SO3. Let's see another question for better understanding. Now, the next question that we are going to do is going to have three elements. I did one question where we were having two elements, sulfur and oxygen. The next question that we are going to do will have three elements in it. All right. Now let's look at question number two. The question says, what is the empirical formula of a compound containing 47.37% carbon, 10.59% hydrogen, and 42.04% oxygen? So as I said in the beginning, just first quickly check if you are getting the sum of all the percentages as 100. So just roughly 47, 10, 57, 42, 99. Yeah, it is coming out to be 100. So that means in my compound, there are these three elements only. What are these three elements? Carbon, hydrogen, and oxygen. So I'll make my column of elements, carbon, hydrogen, and oxygen. So working in tabular form will always help me solve the question in a better way. So now another column I'll make of serial number 1, 2, 3. So again, as discussed, empirical formula is nothing but the formula of the compound in terms of simplest mole ratio. So every time laying emphasis on the fact, on the definition of empirical formula, simplest mole ratio. So first we need to calculate the moles. For moles, you need given mass. Now in the question, you have been given percentages again. So you have to assume the percentages to be given mass. See, if in the question they are giving you mass directly, nothing better than that because moles is given mass upon molar mass. But since they are dealing in percentages, so I have to assume. Unfortunately, I have to just assume. If in any question, by chance, if you get masses directly, just put that given mass over there and calculate moles. So the strategy, the broader strategy remains the same that you ultimately need to calculate moles and moles can, for that you need given mass. For calculating moles, obviously you need given mass. So given mass for carbon, I'll take it as 47.37. For hydrogen, I'll take 10.59. And for oxygen, given is 42.04. If it is percentages, repeating again, if it is percentages, then you will have to assume the percentages as given masses. And if the mass directly is given, like they give you 40 grams of carbon, let's say 10 grams of hydrogen, and something of that sort, then you can directly take the masses. Now, the next column needed is for molar mass, because I have to calculate the number of moles and which is given mass upon this is given mass upon molar mass. So molar masses either refer the periodic table or if you have the knowledge about molar masses in advance, well and good. So for carbon, like I know it in advance that carbon has molar mass of 12, hydrogen 1, and oxygen 16. Next column would be to calculate the number of moles. And for number of moles, the above mentioned formula comes into play. So number of moles is given mass, so 47.37 divided by 12. Over here, 10.59 divided by 1. And over here, 42.04 divided by 16. So I'll use my calculator to do this calculation. 47.37 divided by 12 gives me 3.95 approximately. Then 10.95 divided by 1, I don't need calculator for it. I can simply write 10.59, my bad. And 42.04 divided by 16 gives me 2.63. So it's time to take the ratio now. Moles have been calculated, and for ratio, I just told you that divide all the moles with the smallest moles present. So smallest mole that you've calculated is 2.63. So to take the ratio, divide everything by everything means all the moles that you've calculated by 2.63. So 42.04 divided by 2.63. So again, I'll use my calculator, 3.95 divided by 2.63. So that is 1.5. 10.59 divided by 2.63 is 4. And 42.04 divided by 2.63 is, sorry, my bad. This was 2.63. I'm so sorry. So the moles was 2.63. So I divide this by, so this is 1. So I have simplified it, but it is not coming in terms of whole numbers. Now you have to understand this concept over here. I have simplified the ratio, but it is not coming in terms of whole numbers. In fact, only one value which is coming out 1.5 is not a whole number. So I can simply make it a whole number by multiplying everything by 2. See, there is one other option. If this decimal number would have come out approximately like 1.2, let's say, just assuming hypothetically that if it comes out to be 1.1, then it would have been easier for me to assume 1 in order to take it whole number. But since it is coming 1.5, so it will be wrong to assume it 1 or 2. So it's better you multiply it by a certain number to make it a whole number. So 1.5 into 2 gives me 3. 4 twos are 8 and 2 ones are 2. So my simplest mole ratio becomes 2 is to 8 is to 3. And hence my formula becomes, oh, sorry, it is 3 is to 8 is to 2. I shouldn't change the sequence, no? It was 3 is to 8 is to 2. So my empirical formula technically then comes out to be C3H8O2. This is my empirical formula. Understood? So again, repeating, the idea is to calculate the moles. For moles, if you have been given mass directly in terms of grams, well and good. If you have not been given the masses, then you try to figure out the masses of the elements. And if you're unable to figure out, then if they have given percentages, just try to assume percentages as given masses. Divide them by molar masses using the periodic table, and then just calculate the moles. And when you are taking the ratio, remember to divide the moles calculated with the smallest number of moles. Then you will get the simplest whole number ratio. If you're not getting whole number, try to make it whole number by multiplying by certain factor. But if, again, last thing, that if it is a decimal number coming out to be like this 1.1, then you can take it round off as 1. Not a problem. But generally, you directly get a whole number like you were getting in the previous question over here. You were getting the ratio 1 is to 3. If you're not getting, if you're getting in some 0.5 order, then you can multiply with any number to make it a whole number. Okay, so now let's understand in this last question how to calculate molecular formula. And to be able to calculate molecular formula, we need to take help of empirical formula. That is why we first learn to calculate empirical formula, and then we are learning how to calculate the molecular formula. So let's do one question. Okay, now let's see in this particular question. So like I was talking earlier also, that in some questions, you might be given masses directly. So this is one of those questions where you have been given the masses directly. So this is the best thing. I mean, you ultimately need to calculate the moles, right? And for moles, you need given mass. So mass is technically given, so one should be grateful. Oh, yeah, wow. Anyways, so over here, we don't have to worry about the masses summing up to some particular value. Like for percentages, I was saying that the percentage should come out to be 100. Over here, I don't need to worry about anything. So I'll take it as it is. So carbon, hydrogen, and oxygen, serial number one, two, three. So I'll make one column of serial number, one column of the elements, serial number, elements. Other column would be of given masses. Thankfully, they are given to us in the form of masses only. So no assumptions, no imagination about masses. So given masses is 3 grams, zero point 0.5 grams, and 4 grams. Then molar masses, for that you need to refer to the periodic table if you don't know the molar masses beforehand. But I know it beforehand, so carbon is 12, hydrogen is 1, oxygen is 16. Now calculating the number of moles, which is given mass by molar mass. So 3 by 12, 0.5 divided by 1, 4 divided by 16. Let's calculate the masses. Let us use the calculator. So 3 divided by 12 is 0.25. 0.5 divided by 1 is 0.5 only, and 4 divided by 16 is again 0.25. So we have calculated the mole. It's time for ratio. For ratio, I've told you, whichever is the smallest mole, divide all the moles with that particular mole. So the smallest mole I can see is 0.25. So divide all the moles by 0.25. Over here, 0.5 divided by 0.25. And over here again, 0.25 divided by 0.25. And I can clearly see that 1, 2, 1. So it is automatically coming out in terms of whole numbers, simplified whole numbers. So my empirical formula becomes C. I don't write 1. So it's H2 and then O. So the first part is done. Empirical formula comes out to be CH2O. Now let's understand how do we calculate molecular formula. So always remember, for calculating molecular formula, you will need help of molecular mass. And you will need help of empirical formula here. Therefore, you will be needing empirical mass. So over here, a simple correlation. Molecular formula depends on empirical formula. Molecular mass depends on empirical mass. Now let's see. So the molecular formula given to me in the question, if you see, 88 is my molecular formula. 80, sorry, that's the molecular mass, my bad. So the molecular mass given to me in the question is 88. Molecular formula I have to calculate. Molecular mass is given to me, 88. Empirical formula I just calculated as CH2O. Now with the help of this, can I calculate the empirical mass first? The empirical mass would be carbon's mass is 12 and there is one carbon, so 1 into 12. Two hydrogens, hydrogen's mass is 1 and one oxygen, oxygen's mass is 16. So on solving this, this comes out to be equal to 44. So I can very well see that my molecular mass is 2 times of the empirical mass. So same correlation goes for the molecular formula. Since my molecular mass, look at it over here, that molecular mass is 88. and empirical mass was 44. So I can see that my molecular mass is 2 times of empirical mass. So by that logic, my molecular formula would be 2 times the empirical formula. And when you multiply, since you are writing the formula, remember that the values after multiplying, so 1 into 2, they go into the subscript. So C2, H4O2. So my molecular formula of the compound, this is my final answer, and it is C2H4O2. So for calculating molecular formula, you need help of molecular mass. Your molecular mass depends on empirical mass. How many times does it depend? That factor will be used to calculate molecular formula from the empirical formula. Simple and sorted. And in case if you have any doubts further while solving the questions, do let me know. The chemistry ma'am is always available for you guys. Thank you very much.
If this concept actually made sense in your brain and didn't cause a chemical reaction of confusion, then go ahead and smash that subscribe button on YouTube. And for regular doses of chemistry without the side effects, make sure you follow the Chemistry Mom on Instagram. Thank you.